This video is on estimating square roots to the nearest tenth without a calculator. You need your notebook and the guided notes. So in this video, we're going to estimate square roots to the nearest tenth without a calculator. So we've already worked a little with approximating square roots, finding what integers a square root's between, but now we're going to estimate to the nearest tenth, so get an even closer approximation. So for number 1, we're working with the square root of 12. So the first thing we're going to do is find the two integers the radical falls between. We've already done this. And I noticed they're between the square root of 9 and the square root of 16, those perfect squares. So I know it's between the integers 3 and 4. The next thing we're going to do is use multiplication to find the closest number to the nearest tenth between these two integers. So what I did is I made a number line. The reason I made a number line is to see if the square root of 12 is closer to 3 or closer to 4. So this helped me visualize it a little better. So these dashes, like a normal number line, they don't represent 3.1, 3.2, so don't get confused about that. They represent the square root of 10, square root of 11, square root of 12, 13, 14, 15, 16. So that way I could see if the square root of 12 was closer to the square root of 9 or the square root of 16. So I placed the square root of 12 on my number line right here. So placing the square root of 12 on my number line, I was able to see that the square root of 12 is almost halfway between the square root of 9 and 16, but not quite. So approximating the square root, or just taking a guess, I went with 3.4 because I noticed it's almost 3.5, so I might as well go with 3.4, not 3.5. So what I did was multiply 3.4 by itself to check how close it was to the square root of 12. And when I did that, my answer came out to 11 and 56 hundredths. So that's pretty close to the square root of 12. So I can go ahead and say that approximating the square root of 12, I get 3.4 to be my answer. And it's that easy. Maybe I could have been way off, so my guess was pretty close. So say I guessed 3.2 and it wasn't close at all, you would know to increase your guess and try again. Alright, so now moving on to example 2, the square root of 20. First thing we're going to do is find the two integers the radical falls between. So it falls between the two perfect squares, 16 and 25. So I know my answer is between the integers 4 and 5. Alright, so now making my number line, I'm going to place the square root of 16 and the square root of 25 on my number line, so we can put a 4 and a 5. So then 17, 18, 19, 20, 21, 22, 23, 24, 25. Your number line does not have to be perfect, it's just to help you. So then we have 17, 18, 19, 20. So square root of 20 falls right there. So again, I'm going to guess, it's not halfway, so I'm going to guess 4.4. So 4.4 times 4.4, I get 16. So for my answer, I get 19.36, or 19 and 36 hundredths. So that's pretty close to the square root of 20. So again, I guess pretty good using my number line. So we can say it's approximately 4 and 4/10. Now example 3, the square root of 42. So if you think you're confident enough to try these on your own first, go ahead, pause the video, and then try them on your own, and just use the video to check your answers. So first step, I'm finding the perfect squares the square root of 42 falls between. So I know my perfect squares are 36 and 49. So it falls between 6 and 7. So now my number line, I have the square root of 36, square root of 49, 6 and 7, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. See, that number line did not come out that great, but that's okay. 37, 38, 39, 40, 41, 42. So I'm going to place square root of 42 on my number line right there. So looking to me, it looks like it's about a half. Maybe it's closer to 6, but I'm going to go with 6.5 as my guess. So 5 times 5 is 25. 5 times 6 is 30. Plus 2 is 32. Placeholder, 6 times 5 is 30. 6 times 6 is 36. Plus 3 is 39. So I'm going to add these. I get 5, 2, 12. I get 42 and 25 hundredths for my answer. So it turns out 6 and 5 tenths was a really great guess because 6 and 5 tenths squared gives us 42 and 25 hundredths, and we were trying to get close to 42. So 6 and 5 tenths was a great guess. So let's see what would have happened if we guessed 6 and 4 tenths. Alright, so say on your test you guessed 6 and 4 tenths instead of 6 and 5 tenths. So it turns out 6 and 4 tenths squared gives us 40 and 96 hundredths. So clearly 6 and 5 tenths is a lot closer to 42. 42 and 25 hundredths is closer to 42 than 40 and 96 hundredths. So when taking your test, I would honestly try at least 2 of these. So say you try 6 and 4 tenths and you don't think that's close enough, I would try 6 and 5 tenths. And then you can see which one's the better approximation that you can work with. So the only acceptable answer for this question would really be 6 and 5 tenths because that's what gets you closest to 42. Now let's try the square root of 33. So first step is to find the perfect squares that 33 falls between. So the perfect squares are 25 and 36. So we're working between the integers of 5 and 6. So as you can see, I drew my number line. I placed the square root of 25 and the square root of 36 on my number line. So I can see if the square root of 33 is closest to the square root of 36 or the square root of 25. You don't have to draw a number line. I'm not going to take off points, but I think it's much easier to see which one it's closer to, and then it helps me make a better guess. So I'm going to guess that the best number to work with here is, alright, definitely not 3, is 5.7. So I'm going to try 5.7 squared and see how close I get to 33. So when I chose 5.7 to use to try to approximate the square root of 33, 5 and 7 tenths squared came out to 32 and 49 hundredths, which is really close to 33, so that was actually a really good guess. But let's try 5.8 to see how close we get as well. Alright, so when I use 5 and 8 tenths to see how close we get to the square root of 33, my answer comes out to 33 and 64 hundredths. So both of these answers are really close to 33, so I would actually take both as an answer. But you can see why it's really important to make sure you guess at least twice for these kinds of problems, because one can be closer than the other, or 2 can be really good guesses. So make sure you're always trying at least 2. And your video questions for today are number 1, multiple choice. Which statement is true about the square root of 37? So for that one, you're going to approximate the square root of 37. And for number 2, for your response, is 8 and 5 tenths a good first guess for the square root of 72? Why or why not? So answer these questions in the Google form, and I'll see you tomorrow in class.